Hello and welcome to Algebra 2. Today is Tuesday, September the 8th. We're going to write the date at the top of our page, and we're going to write our topic, which is factors and tables. Okay, before we dive into our real topic for the day, we're going to practice a little bit with converting factors to solutions. So this is our first subtopic, converting factors to solutions. In short, we're going to set factors equal to 0 to do this. Set factors equal to 0. Okay, our first example, we're going to say, what if we had x minus 3? If this was a factor and we wanted it to be a solution, we would write x minus 3 equals 0, add the 3, add the 3, x equals 3. Now it's a solution. Let's label them. This is a factor. This is a solution. Okay, let's do one more example like this. Remember to pause whenever you need, as much as you need. What if we had x plus 5? If I want this to be a solution, I'm going to set it equal to 0 and subtract the 5 over. Okay, this is a factor. This is a solution because it has an equal sign. That's our distinguishing feature. Factors do not, and solutions do have equal signs. Okay, I'm going to do one more, slightly more challenging example. Example 3. What if I had my factor was 3x plus 2? We're still going to start the same way. I'm going to set it equal to 0, minus 2, minus 2. We need to isolate x, so I'm going to divide by 3. And I've got that x is negative 2/3. This was the factor. This is the solution. So we're just setting them equal to 0 and solving for x. Okay. The next thing we have to be good at is converting solutions back into factors. Converting solutions to factors. Okay. So what if I had example 1? What if x equals 4? To convert that to a solution, we need to flip the sign. So my factor is x minus 4. This was a solution. Factor. Let me prove it to you just on this one really quick. Is if I do x minus 4 equals 0 and I add the 4, I'm back where I started at x equals 4. That's why we flip the sign. Okay, one more example here. What if I had x equals negative 2? Well, we just need to flip the sign, and we're going to get x plus 2. This was our solution. We know that because it has an equal sign, and this is our matching factor. Great. Pause whenever you need, guys. Cool. Let's look at the real problem for today. It is this style of problem. We're going to call this example 1. You should pause here and write out the problem. It is so much more meaningful to look back at your notes when you can see the original problem. You need to pause here and write out the problem. Okay, now you've unpaused and you have your problem written out in front of you. Great. So this says The function f is defined by a polynomial. Some values of x and f of x are shown in the table. Which of the following must be a factor? Okay, so before we start this, actually, this guy is pronounced f of x. It means function of x. F of x is the same exact thing as y. This is your new fancy Algebra 2 notation. We're not really going to use y that much anymore. We're going to say f of x. But it doesn't really change much. Whenever you see f of x, think of it as y. This might as well be an xy table. Same exact thing. Okay. Next thing that we need to know when we approach this problem is that we have factors and solutions when y equals 0, not when x is 0. Just like up here, we're setting something equal to 0 to solve, to isolate our x. To get an x isolated, y must be 0. So we're going to say we have potential factors slash solutions, because they come in those pairs, only when y equals 0. Another way to write that is when f of x equals 0. It's the same reason that we're setting these equal to 0 up here. We're making the y part equal to 0. Great. So we know that we're looking for factors, and we know that y needs to be 0 when we have a factor. So our two potentials are this one and this one. Be careful. They try to trick you and put a 0 for x. When x is 0, that does not mean anything special. We're only interested in y being 0. So this solution is x equals -1. Its factor pair is x plus 1. This solution is x equals +3. His factor pair is x minus 3. Always approach the problem like this. Find where y is 0. Write the solution. Write the factor pairs. Then, and only then, do you search for your answer. You're more likely to make mistakes when we look at multiple choice answers first. The only answer I see here is x plus 1. It's not x plus 3 because it's x minus 3. It's not x minus 1 because it's x plus 1. And this x plus 2 tried to trick you here. Pause whenever you need. One last example. You should also take a moment to pause this and write out the original problem. Same deal. Which of the following must be a factor of f of x? Okay, we know that f of x means y. We know that we have a factor when y is 0. This is a potential. This is a potential. This one is not, because it's x equals 0. When x is 0, that does not mean anything special. So over here, I have the x equals -2. My factor pair is x plus 2. On this guy, x is +5. My factor pair is x minus 5. So we're looking for either this or this. Let's see what we got. X plus 5, that can't be it. X minus 2, nope, because we have x plus 2. Aha, here's an x plus 2, and we have no x plus 5. So that's our final answer. That's all for today, guys. Thanks.